Okay, hopefully you're watching this to review for the test that is on Monday. A lot of you asked for YouTube videos to be posted, so here you go. So this is actually within your packet, section 1 in your packet. So when we're solving a quadratic, we're going to factor out an x. Okay, if there's an x you can pull out the x, and you're left with a quadratic in there, and you're going to look for two things that multiply to 14 that add to 9. Alright, so we're going to factor it like we know how, if possible. And this one, x plus 7, x plus 2, 2 times 7 is 14, 2 plus 7 is 9. So this does factor, and fairly quickly we can get x equals 0, x equals negative 7, and x equals negative 2. And we didn't talk about this too much in class, but you can plug, all three of these back in, all right, one at a time. Plug in negative 7 every place there's an x, and you should get 0. So you can check your work too. Number 2, this is another one that it might look like you can't factor it, but you actually can. So I factored out an x. Oops, I forgot my square. Then I'm going to see, there's a couple different ways I can get 6x squared. I could do, 6x times x, and so that would give me the 6x squared. But I might try negative 4 plus 1. And when I try this out and just see if it foils correctly, I see that I get 6x. I'm going to kind of check the middle. I get 6x and negative 4x. That's going to give me positive 2x. I could change the sign like that, see if that gets me anywhere, but that's going to just give me negative 2. Because I'm going to have negative 6 plus 4x. And so forth. So, I tried a couple different combinations with the 6 and the x in that spot, and it didn't work. So, let's start over. So, just working through factoring. I can get 3 and 2. 3x times 2x gives me 6x squared. And then, to get negative 4, there's only a couple different ways. If I try this one, when I FOIL this all out, I get 6x squared plus 3x minus 8x. So negative 8x and 3x make negative 5x. So this works, and you could solve by factoring. So x equals 0. Now you might have to think about these two. Set them equal to 0 and solve. So add 4. And we get 3x equals 4, then divide by 3. So x equals 4/3. And then this one, subtract 1, you get 2x equals negative 1. Divide by 2, you get negative 1/2. So those are my three answers: 0, 4/3, and negative 1/2. Now, if you didn't want to factor, if you didn't want to deal with, trying all the different combinations and factoring, you can always go back to the quadratic formula, and you'll get the same answers. I'm going to do this, I'll show this on the very next one. All right, so this one, when I look for a common factor, I can actually factor out a 2 of the coefficients, and I can factor out an x in the exponents, or in the variables. So I'm going to factor out 2x. I'm going to be left with x squared, because I factored out the 2 and one of the x's. Then 8x plus 3 equals 0. So we still have a quadratic in there. And if I think about it, try factoring this. Two things that multiply to 3 but add to 8, that's impossible. So I have to resort to the quadratic formula, which is negative b plus or minus b squared minus 4ac over 2a. So you have to do this correctly. I think some of us don't know this by heart, and we leave parts out. All right, so negative b is negative 8 plus or minus b squared. So that's 8 squared minus 4. A is 1, c is 3. Over 2 times 1. We need to simplify what's in there. We x equals negative 8 plus or minus. What's in there? We have 64 minus 12. All right, think about that. 64 minus 12 is 52 over 2. Don't forget the 2 on the bottom. And that looks like a pretty good answer. All right, we always want to simplify radicals if we can. And in this case, this is the same as 4 times 13. So the square root of 4 is 2. That comes out. So that's 2 rad 13 over 2. And then everything out front is divisible by 2. So in the end, you're left with negative 4 plus or minus rad 13. Because those cancel out, that becomes a 4. And so forth. And don't forget, x equals 0 also makes this 0. If 2 times 0 is 0, and 0 times anything is 0. So that is also an answer. So this is really 2 answers here. Negative 4 plus radical 13 and negative 4 minus rad 13. Okay, number 4 here. Again, start the same way. And you might start out like that and say, okay, I'm going to factor this thing. Well, 2 things that multiply to 8 but add to 3. Not going to happen. 4 times 2, add those together, you get 6. 8 times 1, that gives you 9. So that's not an option. Okay, you can't solve this by factoring. You got to solve it by quadratic formula. Now, x equals 0 is already an answer, but my other 2 answers I'm going to get by doing some work. So negative b plus or minus b squared minus 4ac over 2a. So I just plug in what I know. Make sure I'm still on the screen. I have negative 3 plus or minus. Put this together. This is really 9 minus 32. That's negative 23. But you can put that all in your calculator and get that number over 2. This is the reason why we did imaginary numbers, because they're going to come back from time to time. We have a negative square root. Can't have that. So it comes out as an I over 2. So there's 2 answers. All right, and you know, to write this as 3 answers, maybe you would say x equals negative 3 plus rad 23 over 2, and x equals negative 3 minus rad 23 over 2. So there's your 3 answers. Okay, this type. The video is getting kind of long here, but it's okay. 125, add that to both sides. We can solve this by, you know, cube roots, if you could call it that way, or just solving it by algebra, because this is all by itself. We already have a cubed. We don't have a squared term. We don't have a single x term. X cubed is almost isolated, all right, all by itself. All we have to do is get rid of the 125, and then the opposite of something cubed is cube root. So that cancels out their opposites. So I have x, and then the cube root of 125 is 5, because 5 cubed is 125. And that's my answer. And if you plug it back in, it's the only number that makes sense. 5 cubed is 125, minus 25, 125 is 0. Same thing. This one, you just have to subtract 216 from both sides. So now I have negative 216 And I got to take the cube root of both sides to get rid of that. All right, and x equals, you can have negative cube roots because -6 times -6 times -6 is -216. That's my answer. All right, the only way to make this a little bit harder is, have two perfect cubes and you end up with a fraction. Add 27 to both sides. Divide by 8. That crosses out. And you need to recognize those two as perfect cubes, because when you go to take the cube root of this thing, all right, that's going to be x. But you got to take the cube root of the top and the bottom. And the cube root of 27 is 3. Cube root of 8 is 2. So 3/2 is my answer. Last one here. So we're going to subtract 1 from both sides. You're going to divide by 64. X cubed equals -1 over 64. And cube root of -1 is just -1. So if I'm a cube root, you can kind of think of this as cube rooting everything. That cancels out, that becomes x. Cube root at the top, that's -1. Cube root at the bottom, and that is 4. Again, always plug it back in, see if you're right. Alright, 12 minutes, we're good. Graphing. Now you notice that this is not set up in a perfect, where you can find your zeros right away. You actually have to factor this. So I'm going to pull out the x like we normally do. And I'm going to try to factor this. Two things that multiply to -15, but add to -7. Now, that's not exactly what you're looking for, because you have to think about, you have a 2x here and then a regular x there. So that's going to give you the 2x squared. So there's a couple of different ways you can get -15. 3 and 5 comes to mind. All right, or 3 and -5. So if that's the first one we try and we FOIL this out, we're going to get 2x squared minus 10x plus 3x, and I know the last part makes -15. So there you go, that middle term makes -7. So I checked it, it's factored correctly. So it looks like my zeros, okay, if I'm worried about where this equals 0, sorry. If I evaluate this at 0, all right, where y is equal to 0, which is the x-axis, all right, x equals 0, x equals, there's 5, and then my other 0 is, if I set that equal to 0, I'm off the graph, set that equal to 0, subtract 3, divide by 2, I get x equals -3/2. Which is just -1.5. So there you go. I know this thing crosses at 0, crosses at 5, and it crosses at -1.5. Okay, so that's not a graph though. I mean, I have 3 points. I'm not sure exactly how this went. Now, earlier in the week, we really sketched these and just tried to get a general idea of what it looks like. And if we remember, if it's positive, it starts down here. So if I just sketch this, I know it goes through about those 3 points. All right, and I know it starts down here, and I know it has this general shape of like an S. All right, I know it's going to look something like that. Probably not exactly like that, but it's going to have that general shape. So after doing all that work, I need to go back to an XY chart. And I might try plugging in -1. Alright, when I plug in -1, I get 6. So plug in as in, I would plug it into the original equation. Okay, so just type that in your calculator. You'd have y equals 2. Parentheses are pretty important there, especially in the second one. So you get the point. You would plug it in for all 3 spots for x, and press enter, and you would get 6. Alright, now I know 0 is 0, but when I plug in 1, I get -20. So that's way off the graph. So I know this thing starts like this, increases pretty quickly, goes down here, and right off the bat, it's way down here. It's off the graph. So just kind of indicate that it goes off the graph. Even 4, when I plug in 4, I'm still at -44. So we can't really show that on this graph, but just know that it goes off the graph. And then 5, 0, or just something like that to finish. Alright, this is going to be the longest video that I've done. Alright, number 2, then we'll be definitely finished. Alright, so y equals, factor out the x, and this happens to be a nice easy one to factor because -3 times -5 multiplies the 15 and it adds the -8. So my zeros are x equals 0, 3, and 5. So I know this thing goes through those 3 points. Okay, again, I know the general shape. This is going to start down here. It's going to do a little S curve. All right, and let's see if what fits. All right, so what x's do I want to use? Well, I want to use x's that are around or in between these points. So I'm going to try 1, 2, 3. I already know. See, when I plug in 0, I get 0. When I plug in 1, I'm curious to see what I get. 2, 3. I already know. I know that's 0. Try 4. And then when I plug in 5, I get 0. So I already know the answers to 3 of these. I need to find the others. So when I do that, when I plug in 1 to the original equation, I get 8. When I plug in 2, I get 6. And when I plug in 4, I get -4. So 1, 8 is right there. 2, 6. When I plug in 4, I get -4. So again, I know the general shape is something like this. Alright, so I know it starts down here. Probably even steeper than that. Through this point and back up. So start with the zeros, find the in-between points, and then graph it.